Hello and welcome back to What Is. Today we're diving headfirst into one of the most mind-bending, existential questions humanity has ever dared ask. A question that keeps astronomers up at night, fuels countless sci-fi plots, and has probably made you stare up at the night sky and wonder, with a slight shiver, where is everybody? We are talking, of course, about the Fermi Paradox. Now, before you picture some ancient alien being named Fermi, let's clear that up. The paradox isn't named after an alien, it's named after Enrico Fermi, a brilliant Italian-American physicist. The story goes that one lunchtime in 1950, while working at Los Alamos, Fermi and his colleagues were discussing a recent UFO sighting and the possibility of faster-than-light travel. One of his colleagues supposedly asked, "Do you ever wonder where everybody is?" And Fermi, with a shrug, simply replied, "But where is everybody?" And just like that, a casual lunch conversation birthed one of the most profound mysteries of the cosmos. So what exactly is the Fermi Paradox? In its simplest form, it's the stark contradiction between the high probability that intelligent extraterrestrial life exists and the utter lack of observable evidence to support it. Think about it. Our galaxy alone, the Milky Way, contains an estimated 100 to 400 billion stars. And the observable universe? We're talking about trillions of galaxies, each packing billions of stars. It's a truly astronomical number. Pun absolutely intended. This isn't just a vague feeling. For decades, scientists have been trying to quantify the likelihood of life elsewhere. Enter the Drake equation. Dreamed up by astronomer Frank Drake in 1961, it's not meant to give a definitive answer, but rather organize our ignorance to get us thinking about the factors involved in the potential for communicating extraterrestrial civilizations in our galaxy. The Drake equation looks like this. N equals R star times F sub P times N sub E times F sub L times F sub I times F sub C times L. Yeah, it's a mouthful, but let's break it down in concept without getting lost in the math weeds. It starts with R star, the rate of star formation in our galaxy. Then F sub P, the fraction of those stars that have planets. Then N sub E, the average number of planets that can potentially support life per star that has planets. Then F sub L, the fraction of those life-supporting planets that actually develop life at some point. Then F sub I, the fraction of planets with life that go on to develop intelligent life. Followed by F sub C, the fraction of intelligent civilization that develop technology capable of sending detectable signals into space. And finally L, the length of time such civilizations release those detectable signals into space. If you plug in even conservative, dare I say pessimistic, estimates for each of these variables, the resulting N, the number of detectable civilizations in our galaxy, often still comes out to be a really big number, like hundreds, thousands, or even millions. And yet silence. Crickets. Not even a cosmic "you've got mail." The universe, according to our calculations, should be teeming with life. Perhaps even advanced civilizations. Many of these civilizations, given the sheer age of the universe, nearly 14 billion years, should have a massive head start on us. Some of them could be billions of years older than Earth. Imagine what a civilization just a million years more advanced than us could achieve. They might have colonized entire galaxies, built Dyson spheres around their stars, or sent self-replicating probes across the cosmos. So where are they? No signs, no signals, no ancient alien megastructures photobombing our telescopes. That, my friends, is the Fermi Paradox in its full, baffling glory. It's the ultimate cosmic ghost town. Now humanity, bless its curious heart, isn't one to back down from a good paradox. Over the years, countless theories have popped up to try and answer Fermi's simple, yet profound question. These theories generally fall into a few broad categories. Either they exist, but we don't see them, or they don't exist, or they're extremely rare. Let's dive into some of the more popular and perhaps most unsettling explanations. One of the most chilling and widely discussed solution is something called the Great Filter. This idea suggests that at some point between the birth of a star and the emergence of multi-galaxy spanning civilization, there is an incredibly difficult, almost impossible step or series of steps that almost all life fails to pass. This filter could be behind us, or it could be terrifyingly ahead of us. If the Great Filter is behind us, it means something incredibly rare and improbable happened for us to get here. Maybe the jump from non-life to replicating simple life is the filter. We don't fully understand abiogenesis, how life first sparked from non-living matter. Perhaps that is the part that almost never happens. Or maybe the transition from simple prokaryotic cells to complex eukaryotic cells, with their tidy little organelles and nuclei, is the filter. That took billions of years on Earth, a huge evolutionary bottleneck. Or maybe it's the development of multicellularity, or intelligent life, or even the jump to tool-making and civilization. If any of these steps are the filter, then we won the cosmic lottery, and we might be alone or among the very first. That's a comforting thought in a sort of lonely way. But what if the Great Filter is ahead of us? This is where things get truly existentially terrifying. It would mean that some catastrophic event or self-destructive tendency inevitably wipes out advanced civilizations before they can expand into the galaxy. This could be anything from global warming, nuclear war, AI gone rogue, bioengineered plagues, asteroid impacts, or even exhausting the planet's resources. In this case, then every time we make a new technological leap, say developing self-replicating nanobots or mastering fusion power, we're not just celebrating progress, but potentially hurtling ourselves closer to the very filter that silenced everyone else. It implies that any civilization that reaches a certain level of achievement is doomed. And that silence out there? It's a graveyard. Makes you want to hug a space rock, doesn't it? Another set of theories falls under the umbrella of they exist, but we don't see them. One of the more famous is the zoo hypothesis. This posits that extraterrestrial civilizations are aware of us, but they have deliberately chosen not to contact us. We're like a protected species in a cosmic nature preserve, observed from afar, but not interacted with, perhaps until we reach a certain level of technological or societal maturity. They're watching us with popcorn, cheering us on, or maybe just shaking their heads, waiting for us to figure out how to stop arguing over silly things. The universe as one giant, slightly condescending reality show. A variation of this is the planetarium hypothesis, suggesting that the universe we perceive is actually a simulated reality, engineered by an advanced civilization. Everything we see, the stars, the galaxies, the emptiness, is just part of a sophisticated projection painstakingly created to make us believe we're alone in the universe. Like a very convincing VR experience. This one really messes with your head, right? Is it even real? Am I real? Are you real? Probably best not to dwell on that one too much before bedtime. Then there's the simpler explanation. Maybe we're just looking in the wrong way or in the wrong place. Our search for extraterrestrial intelligence, or SETI, has largely focused on radio waves, listening for signals that resemble deliberate broadcasts. But what if advanced civilizations use completely different methods of communication? Perhaps they communicate using neutrinos, or gravitational waves, or quantum entanglement, or something we haven't even conceived of yet. Maybe our radio telescopes are like trying to find a high-speed internet connection with an old telegraph. Perhaps they've moved beyond broadcasting altogether, preferring quieter, more efficient methods of information transfer. Distance and time are also massive factors. The universe is unbelievably vast. Even if there are civilizations out there, they could be so far away that their signals haven't reached us yet, or they're too faint to detect. Light, as fast as it is, still takes thousands, millions, even billions of years to travel across the cosmos. We might only be receiving signals from civilizations that are long dead, or sending signals that won't be received until long after we're gone. It's like trying to have a conversation with someone on the other side of the planet, but your message takes 1,000 years to get there. By the time they reply, you've completely forgotten what you were asked. What if they've transcended their physical form entirely? This theory suggests that highly advanced civilizations might evolve beyond biological bodies, perhaps uploading their consciousness into supercomputers or transforming into pure energy. If so, they wouldn't be building giant megastructures or sending out radio signals. They'd be living an entirely different mode of existence, perhaps undetectable by our current methods. They're just chilling in the cosmic cloud, probably judging our primitive meat suits. Then we have what some call the dark forest hypothesis, proposed by the Chinese science fiction author Liu Cixin in his novel The Dark Forest. This is a truly grim prospect. It suggests that the universe is a dark forest, and every civilization is a hunter. Contacting another civilization is incredibly risky, because you don't know if they're friendly or hostile. Therefore, the safest strategy is silence. And if you detect another civilization, the most logical course of action is to destroy them before they can destroy you. It's a cosmic game of hide and seek where the stakes are annihilation. In this scenario, the silence isn't empty, it's terrifyingly deliberate. Now let's explore the other main category of answers. They don't exist, or they're extremely rare. This brings us back to the Great Filter, but from a different perspective, one where we are the exception rather than the rule. The rare Earth hypothesis argues that the specific conditions on Earth that allow for the evolution of complex life are incredibly rare, perhaps unique. It's not just about the planet being in the Goldilocks zone, not too hot, not too cold, but a whole host of other factors. We have a large moon stabilizing our axial tilt, ensuring relatively stable seasons. We have Jupiter acting as a cosmic vacuum cleaner, deflecting dangerous asteroids. We have plate tectonics, recycling nutrients and regulating our climate. We have a protective magnetic field, getting all of these planetary features just right, in the right kind of star system, in the right part of the galaxy, at the right time in the universe's history. It might be an astronomically low probability event, so life might be common, but complex, intelligent life, that's the real cosmic unicorn. A related idea is that life itself might be common, but the jump to intelligent, and especially technological life, is what's rare. Think about Earth. Life appeared relatively early, within 1 billion years of the planet forming. It took another 3.5 billion years for anything resembling intelligence to evolve, and only a tiny fraction of species ever developed the kind of technology we possess. Dinosaurs ruled for 150 million years and never once built a radio telescope. Maybe intelligence isn't an inevitable evolutionary outcome, but a rare quirk, a side branch on the tree of life. So with all these theories swirling around, what exactly are we doing to answer Fermi's question? Well, we haven't given up hope. The search for extraterrestrial intelligence, or SETI, is still very much active. Projects like the Allen Telescope Array in California are constantly scanning the skies, listening for any artificial signals. While primarily focused on the radio frequencies, there are also efforts in optical SETI, looking for brief, powerful flashes of light that could be intentional laser communications. It's a painstaking process, sifting through mountains of data, but the hope of detecting even a faint whisper from another civilization keeps the lights on. We've also done a bit of shouting into the void ourselves. The Voyager and Pioneer probes, launched decades ago and now streaking out beyond our solar system, carry golden records and plaques, messages in a bottle if you will, containing sounds, images and diagrams of life on Earth. intended for any extraterrestrial civilization that might intercept them. It's our cosmic business card, hoping someone finds it and gives us a call. Perhaps our most promising avenue of discovery lies in exoplanet research. Missions like the Kepler Space Telescope and now the Transiting Exoplanet Survey Satellite, or TESS, have revolutionized our understanding of planets outside our solar system. We have gone from speculating about other worlds to confirming thousands of them, many in the habitable zones of their stars. This data helps us refine the Drake equation parameters and identify promising targets for further investigation. And the next generation of telescopes like the James Webb Space Telescope, or JWST, is pushing the boundaries even further. While it can't directly image alien cities, it can analyze the atmospheres of exoplanets, looking for biosignatures, chemical compositions that might indicate the presence of life, things like oxygen, methane, or even unusual combinations of gases that would be difficult to explain without biological processes. It's like sniffing for clues from billions of miles away. There's also the Breakthrough Listen project, a massive, privately funded initiative that's conducting the most comprehensive search for alien communications ever undertaken. Imagine scanning 1 million nearby stars, 100 nearby galaxies, and even the galactic plane for unusual radio and optical signals. They're essentially casting a much, much wider net. Ultimately, the Fermi Paradox remains unsolved. We continue to search, to listen, to probe, driven by that intrinsic human curiosity to understand our place in the universe. Are we alone? Are we one of many? Are we a cosmic anomaly, a miracle against all odds? Or are we simply living in a quiet neighborhood of a very, very big city, just waiting for someone to finally throw a party? The silence is profound, but it's also a canvas for our imagination, a challenge to our scientific ingenuity, and a constant reminder of the incredible mysteries that still lie beyond our grasp. It forces us to confront our own potential, our own fragility, and our own destiny. So the next time you look up at the stars, instead of seeing just twinkling lights, remember the deeper questions they pose. And remember the answer, whatever it may be, will redefine humanity's understanding of itself forever. Thank you for joining us on this mind-bending journey through the Fermi Paradox. If you enjoyed this cosmic deep dive, please give this video a big thumbs up, share it with your fellow stargazers, and don't forget to subscribe to What Is for more episodes that unravel the universe's biggest and smallest questions. Hit that notification bell too, so you never miss another journey into the unknown. We love hearing your thoughts, so tell us in the comments below, what is your favorite theory for solving the Fermi Paradox, and where do you think everyone is? Until next time, keep looking up.